Hello everyone and welcome to week 7. This week as I look in your syllabus I see that we're supposed to be talking about balanced logic and bug collections, which is a really fun way to look at some algebraic type thinking. So as you look at this you'll see what I think bug collections are is an easy understanding for kids to see, easy way of understanding for kids to see the math behind a real world problem. And I put real world in parentheses or in quotations because we derive a lot of problems as we go along and we just call them real world. It's a doable thing, but clearly my examples will be contrived. So these collections, for doing these collections, we're going to use some centimeter cubes. So you don't have to have these at home, but if you have centimeter cubes or some kind of color tiles that you've made in a 350 or a 351 class, they might be helpful. You're going to see that we're going to call different things different colors, and it might help me out as I work with young kids to have a lot of color tiles or in this case centimeter cubes, right? So I'm going to work with centimeter cubes up here and show you what I'm doing as I do it, and you can work along. What you're going to see is I will upload in D2L a lot of these bug collections, several of them, so that you can see what I work and then you can see what's for homework and work along. So the bug collections, here's what it says. The science class is collecting insects. What they're going to do is catch them, study them carefully for an hour, and then of course we're going to let those poor little bugs go. So we don't want to be mean to the bugs. So all collections have, and here's the important part, ladybugs, grasshoppers, and crickets. And it even says, use cubes to show the insects and solve the problems below. Okay, you can see that in the thing I have my little box, my insect board, whatever you call it. Okay, so that I can study these guys. And then there will be pretty much on each of these 4 problems for you to work with. And there's going to be different things that happen, so we'll work through some of them. So we're doing collection number 3. Collection number 3 says, and we're just going to pick number 1 here, that Jack has a collection, and he picked up, as he was going along, 2 grasshoppers and twice as many ladybugs as grasshoppers. Ladybugs, I'm probably going to get lazy here in a little bit and start abbreviating that. But for right now, I'll write out ladybugs and grasshoppers. This is where, by the way, this is how we come up with variables to stand for things, right? We just get lazy as mathematicians and say, I'm not going to write out ladybug, I'm going to use an L or whatever. And he knows that there are 9 insects in all. And your job is to determine the number of each kind. So there will be L equals and G equals. And the other one that was in there was crickets, right? So C equals. So those are the things that he has available to him. That's all of our knowledge, and we're expected, working with kids, to be able to figure out the solution to this. And this one's a fairly easy one. I started us out pretty easy. Just going to get our feet wet, so to speak, and then we'll try some harder ones. So let's go. Grasshoppers, I think grasshoppers start with a G and green starts with a G, so I'm going to use green for grasshoppers just because in my brain those go together. If you want to pick a different color to represent grasshoppers, then go for it. It will not matter a bit. Okay, so for my problem, green is for grasshoppers, and I need twice as many ladybugs as grasshoppers. So to me, ladybugs are red. So my red cubes are going to represent the ladybugs. And if I were working with children, middle schoolish children, I would say, okay, how am I going to represent twice as many? And there's lots of ways for them to talk about twice as many, right? If they know, oh, 2 times 2 is 4, then great, they can come up with that, no problem. Or they can say, I have one group of 2s and I have two groups of 2s. That's twice as many groups, right? Or they can say, hey, look, here was 1 grasshopper. For every 1 grasshopper, I'm going to make 2 grasshoppers, or 2 ladybugs, sorry. And for every 1 grasshopper here, I'm going to make 2 ladybugs here. So I know I have twice as many there. It's twice as many per item, right? So I can do twice as many groups or twice as many per item in each group. So here's 1 item per group. I got 2 ladybugs per group, 1 grasshopper per group, 2 ladybugs per group. Okay. So whichever way, we see that's awesome. I've got this many bugs sitting out there, and we knew for sure there were 2 grasshoppers. That was given, right? So let me stick that up there. And now we know that twice as many ladybugs is 4, which of course, as adults, it's a little easy for us to do that. But remember, the idea behind these math ed classes is that we're supposed to be preparing you to one day be the teacher of record. So hopefully, we can kind of look and say, okay, what's going on here? And then what do you think that Jack's going to do to figure out how many are crickets? That's the only one I got left, right? How many are crickets? Well, we use this piece of information, and we use that piece of information. So now I need this piece of information, which says, hey, there are 9 insects at all. And I know there's already 6 out there. So if the ladybugs are taken care of and the grasshoppers are taken care of, everything else has to be a cricket, right? So I've got 6. I need to work my way up to 9. For me, we'll call black ones crickets. How's that? Crickets are black. That makes sense to me. This is how things are in Webster World, guys. Sorry if that doesn't make sense to you. But to me, I'm saying 6, already taken care of, 7, 8, 9. So there must be 3 crickets, right? Okay. So I think there's 3 crickets. There's my answer. No problem. So when you're working with the young kids, it's going to be very nice that you do these kinds of things with them so that they can kind of see, okay, what's the process going on there? And again, I had lots of kind of mathy things going on. I doubled, or I used multiplication. I used groups or items. And then I added up to get to the 9, right? So that's a different kind of arithmetic skill going on there. So lots of math going on here in the background. Even if as adults we think it's not too bad, as students, let me tell you, sometimes it's pretty bad. Okay, what you'll find is as we go along, these problems will get a little more difficult in their math, so to speak. So here's Wayne's collection, number 2 on that guy. He has 6 insects in all. He knows that half of the insects are grasshoppers, and I'm just going to start abbreviating grasshoppers. Sorry about that. And he knows that a third of the insects are crickets. Okay. And again, we have the old L equals G equals C equals, and they ask me to work it out with cubes again. So at some point, we know that we'll want our students to go from this concrete model with the cubes to an abstract model, right? That's one of the habits of mind we want to develop. But we like to kind of do a little bit of this as we go along and say, hey, what's going on? Okay? So if I start out with this, I'm like, I don't know how much is what, okay? So I'm going to start with, can y'all see that yellow? Maybe you can't see the yellow, sorry. How about white? It's not much better. How about blue? Blue will work. Okay, everything's going to be blue at front. Y'all can see that one. Okay, everything's blue. I know I have 6 insects in all. I don't know anything about them just yet, just that they're insects. So I start with all of them, not one of my other colors. So remember, I'm using red, green, and black for the 3 particular insects I've got there. So as I do this, if I have the total group already sitting here, then I can start splitting it up in different ways. And notice that these are my fraction skills, right? That's definitely a middle school or higher skill. And I don't want you to think, oh my gosh, I'm going to be teaching high school, so I don't care about middle school skills. You definitely care about middle school skills because guess what? Teaching college, I still have problems with students with fractions. So it doesn't just go away just because it was an elementary or a middle school skill. Okay, we need third grade skill of multiplication. I need them to be able to do that so they can factor a trinomial in college. Okay, so any skills, we all build on each other. We want them there. Okay, so here I go. I got 6. I need half of them to be grasshoppers. So I can certainly split these up 3 and 3, and students will start remembering or learning or whatever that halves means I need one group out of the 2 groups, because these are individual set items, right? I need one group out of the 2 groups to be grasshoppers, okay? And then, while I'm still thinking about it, while I've still got them all blue, what does this mean fraction-wise? 1 out of 3, 1/3. I need one group out of 3 groups to be crickets, right? Let me put it over there. Okay, I need one of those 3 groups to be crickets. So that means if I just move them around like this, I know for a fact 1 out of 3 groups will be crickets. So 2 of them are crickets. And I also know for a fact 1/2 of them were grasshoppers, right? So 1 out of those 2 groups is grasshoppers, which means how many? 3 are grasshoppers, right? So now I can come in and kind of go, okay, you 3 guys, y'all are all crickets. You're not just generic blue insects anymore. And 2 of you are crickets. I mean grasshoppers here, right? Crickets here. So that leaves me 1 generic insect left over, and he's got to be, or she's got to be, a ladybug, right? So now I can come back and I can check my group. I can make sure 1 plus 3 plus 2 gives me the total of 6, which it does. I can clearly see half of my insects are crickets, right? Or I'm sorry, grasshoppers. They're so similar, grasshoppers and crickets. They should have picked something else. I don't know. Okay, so there we go. Half of them are grasshoppers. And I can also see that if I split this into thirds, 1/3 of them, or 2 out of the 6, 2 out of 6 will reduce to 1/3, right? 1/3 of them are the crickets. Okay, so I've met all of my conditions up there. I have 1 ladybug, got all my blanks filled in. I'm good. Hope that's okay with everybody. If it doesn't make sense, go back and rewatch that little bit of the video. So hopefully that kind of gives us an idea for what's going on with these collections. Let's just finish this out. There's 2 more problems on this page. One is number 3. It says Veronica's collection. Her collection is 12 insects total. 1/4 of them are ladybugs. 1/3 of them are crickets. And of course she's got the blanks, L equals, G equals, cricket equals. We don't know, but we're going to find out, right? Okay, 12 total. So if I've got them, I'm going to stick up 12 blue guys here because they're the generics for me. Again, if you have something you can play with here, fine. If you're like, I don't have any color tiles, I don't have any centimeter cubes, you could always pick like pennies and nickels and dimes, right? Make one represent one and one represent the other. I had a student one time who used small paper clips and bigger paper clips. So whatever it is that helps you, that'll be okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, here's my group, 12. 1/4 of them are ladybugs. So what do you think I need to do? Split them up into fourths, right? So we as adults know that 12 divided by 4 is 3. But if I wasn't sure, I could totally just split them up, partition them out, do repeated subtraction, whatever you need to do to make sure that you've got it split up so that you know there are 3 in each of those fourths. Okay, so a fourth of those are ladybugs. So I'm going to go ahead and switch out 3 for ladybugs. Okay. So 3 ladybugs. They're still in there, but they're already kind of accounted for, right? Okay, and then a third of them are crickets. So I need to think to myself, what would be a third of 12? Well, that would be 4, right? Okay. Now, I don't want to use this third because I've already got some of them designated as ladybugs, right? So I'm going to use this third over here. There's 4 in each third, and that means 4 crickets. Okay. I was using black for those. 4 crickets. All right. 4. There we go. And then that leads me to say, okay, how many are left over that are grasshoppers? Now, we could just put all the blues together, right? Or I can flip them out for greens if you need me to. 1, 2, 3, 4, 5 leftovers. That's 5 grasshoppers. So really easily, I'm just going to switch those out. That's how many are grasshoppers. And then to double check myself, I'm going to always come back and count, right? So 5 plus 4 is 9, plus the 3 is 12, and I've got 3, 4, and 5, so that's got to be the 12. So I feel like I'm pretty good there. All right. The last problem on this page is number 4, and it's very much similar to what we've already been doing. They've got some fractions in there, so I'm going to let you think about it for a minute. If you've got some kind of manipulative there at your house, pennies, nickels, and dimes, or actual color tiles, whatever it is, you can do Alvin. 10 insects in all. 1/2 of the insects are ladybugs, and 1/5 of the insects are grasshoppers. So as you're working on that, go ahead and figure it out. As adults, again, it's pretty good for us to say, hey, I know if there are 10 of them and 1/2 of them are ladybugs, that means that 5 are ladybugs. So if you're making your collection, 5 ladybugs. And I know that 1/5 of them are green or grasshoppers, so those are going to be green. That's 2. And the rest are going to be crickets, so there should be 3 of those guys, so that everything adds up to 10. And then once I've got this out here, we can double check. There's 1/2. The 5th might be a little bit difficult. There's my 1/5 that's green for grasshoppers, and then all the leftovers are crickets. Okay, so whatever you need to do to be able to understand, this is what young kids are doing with this. This is up through about the middle of middle school, okay? And then somewhere, I always say, I really feel for middle school math teachers, because bless your hearts, y'all are the ones who have to make that transition. So this is what they've been doing in elementary school. This is what they're doing in 5th grade, maybe a little bit in 6th grade. Maybe you even do this to wake them up and get them started on some of this. And then poor 6th, 7th, and 8th grade, we've got pre-algebra and algebra, 8th grade math, all that stuff. And we have to start learning those abstractions and learning how to go from this mindset of the concrete to, okay, what does that mean for us conceptually? So I'm going to work conceptually now. So everybody hold on to that thought. I'm going to give you collections number 13. It's very similar to what we've been doing. Here's my insect box. Again, similar stuff going on here. We're going to look at Paul's collection. Excuse me, number 1 there. And we're going to work it out, but if you need to, you can do some block stuff, some centimeter cubes, whatever. But what you're going to see is Paul starts being a little more abstract with the way we talk about him. It was bad enough, so this is collection 13. It was bad enough whenever we were doing fractions in collection number 3, right? But now Paul's being a little bit abstract with us. He thinks he's cute, okay? He says he has 3 times as many ladybugs as crickets. And he says he has 1 more grasshopper than ladybugs. And he knows that he has 15 in all. 15 total. Okay. So here's the trickiness about the Paul collection here. Let me scoot that up a little bit. The difference about Paul is that we don't know a set number of any of them. So in the other ones, for instance, let me come back here a minute. In the very first one we did, we had 2 grasshoppers, right? We knew, boom, 2 grasshoppers. And even though they didn't tell me exactly how many ladybugs, I could relate that back to the number of grasshoppers, right? Twice as many as the grasshoppers. So I had to think, okay, how does the ladybugs relate to the grasshoppers? But at least I had an idea, right? Here in Wayne and then Veronica, the next 3, they were all fractions, right? But we've had fractions of the total. So 6 insects, take half of them, take a third of them, okay? Here, Paul's not being quite so deliberate. I don't have anything that's exactly a portion of the whole, right? My entire group here is 15, but I don't have anywhere that it says half of them or a third of them or a fifth of them. And I don't have anywhere that says there's 12 ladybugs, right? So I don't have any of that stuff going on for me. So this is where it's a little more abstract, and it's going to be difficult for me to get the number. So for instance, I'm going to look at it and say, because we're looking for, I should have left myself some space, L equals, G equals, C equals, there we go. I'll put it right there on the side. Excuse me. Way better this week, by the way, guys. Sorry for coughing all over you last week. Okay. So we're going to look at it and we're going to say, okay, in both of these first 2 statements, we have 3 times as many ladybugs as crickets. 3 times as many ladybugs as crickets. So that means what? The ladybugs here, 3 times as many ladybugs as crickets. The as crickets is what I'm referring to, right? So here, let's go back and think about it. Twice as many ladybugs as grasshoppers, right? That was number 1 that we did. We knew 2 grasshoppers, so we multiplied that by 2 to get the 4 ladybugs. Okay, but the as grasshoppers, that bit is what told me I'm referring to the grasshoppers, right? So let's think about it. 3 times as many ladybugs as crickets. So I'm referring to him. Right? That's how I'm getting the ladybugs. So what that means for me is if I know that there are 2 crickets, then there's 3 times as many ladybugs. How much is that? 6, right? So then I know, okay, I would need 6 ladybugs. I'm short of red. I'll use a pink. Okay, I would need 6 ladybugs, right? And then there's 1 more grasshoppers than ladybugs would be 6 plus 1 would be 7. There would be 7 grasshoppers. But then I go back and I go, but wait, there's supposed to be 15 in all, right? So 6 plus 2 is 8 plus 7. Oh, that is 15. Oh, I cheated. I totally just guessed it, okay? So that would actually be my answer. But normally it's going to be difficult for me to just pick out of the blue, right? Let me pick another number. What if I thought there were 3 crickets? Okay, then there would be what? 9 ladybugs. And then there would be 9 plus 1, 10 grasshoppers, right? So then I'd have 10, 9, and 3. That's way too many. Okay? So it's going to have to be based off of what am I referring back to? Is what I need to think about. So here, my crickets is what I'm referring to with the ladybugs. And then I have 1 more grasshopper than ladybugs. So the grasshoppers are being referred to as in terms of as the ladybugs, right? So actually there's several different ways you could do this. I'm with the algebra. I'm going to make the crickets be my unknown. Let C be total number of crickets. Okay, I have a friend who did this one and totally made L be the number of ladybugs. If you want to make L be the number of ladybugs, that's okay. There's lots of ways for us to go about this. You can totally do that. Your math in between is going to look a little different than mine, but at the end we're going to end up with the right number, right? The correct number. Okay, so if C is the number of crickets, then how can I come up with ladybugs? 3 times as many ladybugs as crickets. So L better be what? 3 times as many as crickets. So 3C. Does everybody agree with that? Okay. So then I know, hang on, but grasshoppers, that's going to be my G here. Grasshoppers is equal to the total amount, one more than the ladybugs, right? The total amount of ladybugs plus 1. So normally I would say ladybugs plus 1, L plus 1, if you want to do that. But in my brain I'm thinking, I don't want a different variable in here. Wouldn't it be nice if I started with C here, that's my unknown, and I've got a C there, that's my unknown. If only I could continue working in C's instead of having to go back and forth between L's and C's and whatever. And so instead of saying the number of ladybugs plus 1, I'm going to do a substitution here, right? And I'm going to put that whole thing in there. Now, you could come in and do ladybugs and then back substitute if you want to. I'm just going to go ahead and put 3C there. Okay? All right, so I've got 3 little things here. This is my crickets, this is my ladybugs, this is my grasshoppers. And I know that my whole entire collection is all 3 of these added together, and that will give me a total of 15. Okay? Because all of our collections have had these 3 types of insects, ladybugs, crickets, and grasshoppers. And that's all I've got. I don't have any worms or whatever in here, right? So I know that crickets plus the number of ladybugs plus the number of grasshoppers is going to give me 15, right? But we just did this little arithmetic step here, or algebra step, and I'd like to use that, right? So I know crickets is just a C, but I know ladybugs can be demonstrated as what? Yep, L equals 3C. 3C, and grasshoppers can be 3C plus 1. Now some people like to put those in parentheses, and if I was doing any kind of subtraction, you could totally do that. It's not necessary right here, but it's not a bad habit to get into. All right, now we have a good old-fashioned what? Equation. And if I look at it, I can do this math fairly quickly. 3C plus 3C is 6C plus 1C. That's 7C's plus 1 is equal to 15. And this just becomes an algebraic equation. And for our purposes, we're going to assume that we can actually substitute or solve these. And then later, whenever we do the balancing problems, we'll see how that goes. Okay. So if I wanted to solve this, we know, subtract 1 from both sides. What I do to one side, I have to do to the other, so keep it nice and even. 7C is equal to 14. Okay, and then I know what? I'm trying to solve for C here, right? So divide by 7, do it to both sides. What I do to one side, I do to both. C is equal to 2. Oh, that's the number I guessed earlier. I totally just guessed. I really didn't know that answer. Sorry, guys. Okay, so we know that there are 2 crickets. Awesome. And I know that I should be able to find all of my animal or insects this way, right? So let's back our way up. We know that ladybugs was 3C. Okay, and now we know that C is 2, so I need to back substitute. 3 times 2 is 6. So now I know that the ladybugs are 6. What I had earlier. And then last but not least, I know that grasshoppers is equal to ladybugs plus 1, or I had it 3C plus 1, right? But we know that ladybugs is 6 now, so that's 6 plus 1, or I could substitute in there. Either way, I'm getting 7. Okay. So 7 for the grasshoppers. Okay, so 6 ladybugs, 7 grasshoppers, and 2 crickets. Okay, we got that. I kind of guessed it earlier. It's kind of got a feel for it, but now we can see exactly what's going on in there, right? Okay. So, questions about that? If you're not sure what's happening, go back, rewind the video, send me an email. I'm assuming that everybody's algebra skills are good enough to follow this, but I know that could be a big assumption. So if yours aren't, and if you need help with solving an equation like this, just let me know. I'll be glad to work with you. Okay? All right. So as you can see, collection 13 is a lot more abstract and a lot more advanced than what we would have had for collection number 3. Collection number 3, I was able to use the cubes a lot better, right? But here it's a little bit more difficult. I might have to do a little more guess and check. So, boy, it would be nice if I could develop those algebraic skills and do some doing and undoing, right? That's what I was doing when I was solving. So doing and undoing is always good. Terry. All right. Terry says there are 1/3 as many grasshoppers as ladybugs in his collection. Could be her. I know some Terrys that are girls. 2 more crickets than the grasshoppers, and there's 17 insects in all. 17 insects total. So again, I'm going to do ladybugs, grasshoppers, crickets. We'll figure that out. So I'd like you to think about this one a second. See if you can decide which thing I'm referring to. 1/3 as many grasshoppers as ladybugs. 2 more crickets than grasshoppers. Make those grasshoppers. Okay. Since last time I used the one I was referring to, this time I'm going to use the one that's kind of in the middle. So grasshoppers is kind of in the middle. So let me show you how I would do this one if I needed to set up those equations, because we did it the other way earlier. So I'm going to do it this way this time just because I didn't do it this way last time. So if I was using the grasshoppers, they're kind of the pivot guy. They're in the middle here. As my, my unknown, then I'll let G be grasshoppers, which in this case what I'm doing is letting it be my independent variable. Right? It's my independent variable. So I can do whatever I want to with that. Okay. There's 1/3 as many grasshoppers as ladybugs. So G equals, compare that to the ladybugs, 1/3 as many as ladybugs. G equals what? 1/3 of L, right? Or I can flip that around and say L must be, if G is 1/3 of L, then L must be 3 times as much as G, 3G. So I've got a nice little equation there. Now, if that bugs you, then you can also do the arithmetic here, the math here, right? In order for me to get the L completely by itself, to get rid of the 1/3, I would need to multiply both sides by a 3. 3 over 1 will reduce that out, right? And that gives me L equals 3G. So if you can't just jump to the conclusion I did, it's okay. You can actually do the algebra there and reason it out, right? Make sure you've got it. So L equals 3Gs. And then what do we know about crickets? Crickets was what? 2 more crickets than grasshoppers. So if I look at the grasshoppers, then I've got crickets equals 2 more than the grasshoppers. So grasshoppers plus 2. Okay. And I also know this little side statement that we had earlier, the total was 17. So L plus G plus C equals 17, right? I know that piece of information because my total is 17. So keep that in mind. So now I don't want to use that though. I'd like to use what we've been going through here. So instead of L, we would use what? 3G. Okay. Instead of, well, G is actually my independent, right? So plus G. But instead of C, I'm going to use what? G plus 2. What we're doing here is we're rewriting all of this stuff. Instead of having 3 little equations, one about ladybugs, one about grasshoppers, one about crickets, 3 separate equations, that would be kind of annoying and hard to keep up with all the variables, right? Especially for kids that are just learning algebra. I don't want to use 3 variables or even 2 variables if I don't have to. So instead, this is kind of a middle school process. What I'm doing is I'm making them all be in one particular variable, right? Now later, as I get stronger in my algebra skills, I might need a system of equations, right? But for now, I can work this entire problem in one variable, which is a middle school skill, and be able to solve this. So let's see. 3 plus 1 is 5G's, plus 2 equals 17. Is everybody okay with that? And then I see, oh, I want the 5G's by themselves, so I'm adding 2. So I want to move that to the other side or undo that addition. I'm going to subtract 2. But whatever I do on one side, I have to do to the other. So I just make sure that everything stays in balance here. Okay, so as I go along, 5G's is equal to 15. And now I say, oh, I've got G times 5, I'm multiplying, so to undo that multiplication, I need to divide by 5. But again, to keep the balance, I need to do that to both sides. So 15 divided by 5 gives me 3. G is 3. Okay. Which means that C is easy to pick up, right? C was G plus 2, so 3 plus 2 is 5. C equals 3 plus 2 equals 5. Got that one. That's pretty easy. And then what about L? L was up here at the top. 3 times 3, right, would be 9. So L equals 3G, or 3 times 3, which is a 9. Whee! Okay, so now I have all 3 of those amounts going for me. I'm going to just double check real quickly, so let me throw them up here. I've got in my answer block here, ladybugs was 9, crickets was 5, and grasshoppers was 3. So in my brain, I just do a fairly quick check and try to figure out what's going on here. I look for this relationship, grasshoppers versus ladybugs, and indeed, there are 1/3 as many ladybugs as there are grasshoppers, or I'm sorry, 1/3 as many grasshoppers as there are ladybugs. So in other words, ladybugs is bigger, grasshoppers is 1/3 of that. Okay, yep. And whenever I look at grasshoppers versus crickets, crickets has 2 more, yep. And then I'm going to total them up. 9 plus 3 is 12, plus 5 is 17. So my total insects is 17. I'm good. Okay. So hopefully that starts to make sense. I'm going to do one more problem. I think it'll help us. And then we'll be done with today's video. And then I'll let you do some homework off of this and some participation. So, in fact, I think that this next problem right here is going to be your participation grade for the week or for the day. Collection number 10. Problem number 1. Okay, so let me throw this guy up here. Collection number 10, problem number 1 is Bernie's collection. The same number of ladybugs as grasshoppers. 1 more cricket than ladybugs. 10 insects in all. Okay. All right. Okay, here we go. So, I'm sorry, in my brain that just didn't make sense, but I got it now. I've got it going. Okay, Bernie's collection says, same ladybugs as grasshoppers. One more cricket than ladybugs. And he has 10 insects total. Okay. L equals, G equals, and C equals. All right. So let's talk about Bernie, shall we? Same number of ladybugs as grasshoppers, which means L equals G. It doesn't really matter which direction I go. But as I look at this middle statement here, one more cricket than ladybugs, I see again I'm referring to ladybugs, right? So I would just like to kind of use my ladybugs as my unknown. So I'm going to let L be ladybugs. Okay, and at some point you're going to have to give me that statement that tells me which variable are you using as your independent variable. So this is my independent variable, meaning whatever happens to ladybugs, that will help me determine what's going on with the others. The others depend on what happens with the ladies. Okay? All right, so I'm letting L be the ladybugs, which is my independent variable. I know that the same number of ladybugs as grasshoppers, L equals G, right? Because they're the same number. And then how am I going to do one more cricket than ladybugs? C equals, yep, L plus 1, right? Okay, so these are actually going to be fairly easy. The trick here being that L plus G plus C equals 10. That's my known, right? I know how many total there are. I need to use all the pieces of information. I'm not going to be able to solve these if I don't use all the pieces of information. So as I look at that, I say, okay, L plus G plus C equals 10. The trick is what? The L and the G are the same thing. So if I'm using L as my unknown here, then I've got L plus, and instead of G, I'm going to write L, right? Plus, and instead of C, I'm going to write L plus 1, right? Okay, and if you want to, you can always put that in parentheses. And all of that is going to equal the total, which is 10. Okay, so ladybugs plus grasshoppers plus crickets equals 10. All right, now this becomes fun because I've got 3L plus 1 equals 10. Whenever I undo that addition there, I get a minus 1, minus 1. And I see, hey, 3L equals 9. It's an L. So now I can undo multiplication by dividing, right? So divide by 3 on both sides. The L would be equal to 3. 9 divided by 3 is 3. So there are 3 ladybugs in his collection, right? Bernie's got 3 ladybugs. And what does that tell me about the G's? Grasshoppers. Also 3, right? They're the same. And then what does that tell me about crickets? Well, they're kind of being a little bit crazy or tricky or whatever because they say the crickets is ladybugs plus 1. But you could just as easily use grasshoppers, right? Because we know they're interchangeable. But I'll use ladybugs plus 1. 3 plus 1 is 4. And when I do my little arithmetic thought process there, 3, 3, and 4, I know 3 plus 3 plus 4 is 10. So that does give me the total amount that I'm after. So all of that is lovely, right? All right. So we're going to go ahead and do number 2. Number 2 says Diane's collection. She's got the same number of crickets as ladybugs. I'm totally getting lazy and abbreviating now. One more grasshopper than the ladybugs. I'll put the B in there. And there are 13 in all, so 13 insects total. All right. All right, so y'all go ahead and work that real fast. I think we're far enough that maybe you've got a good idea. Tell me which one you want to use as your independent variable. In my brain, this one's related to the ladybug, so I'm going to use the L. But if you don't want to, use one. Use whatever one you want to. Do it the other way. Then check your answer and see if it matches mine. So I'm letting ladybugs be L, and that's my independent variable. So I'm saying, hey, wait a minute. I know C equals L. We did this a second ago. And I know there's one more grasshopper than ladybugs, so grasshoppers equals L plus 1. Hopefully you guys are zooming along. I've got L plus L plus L plus 1 is 13. 3 L's plus 1 is 13. 3 L's is equal to 12. L is equal to 4. Do the arithmetic there, the algebra there. So I know that ladybugs is 4. Grasshoppers is the same. No, I'm sorry, crickets is the same. Let me be careful. Crickets was the same, so that's 4. And then grasshoppers was ladybugs plus 1. So grasshoppers is equal to 4 plus 1 is a 5. And double checking my math real quickly. 4 plus 4 is 8. If this was a plus 4, it would be 12, but it's plus 4, so it's 13. So that adds up. So I'm good. Awesome. I like it. Love it when a plan comes together. Okay, so there we go, and you will get your participation on the housekeeping video, so take a look at that real fast, and you'll figure it out. All right, thanks.